me have a quick look on what is the topic is all about. So hashing, you know very well, in order to have effective storage and effective retrieval of data, hashing is used. We have seen during our search, even linear search, uh, binary search, it will take some time, more time to, uh, in fact, search. But if you want to have a search, if you want to have a search, so with the order of one, then certainly we have to go for we have to go for uh, this particular hashing technique. So there are two aspects that you have to consider. One is hash function, and another one is hash table. So hash table is the one that is being used for storing the elements, and hash function redirects it. This I have already discussed in the class. So this is hash table. So and your hash function is a function that generally calculates some function, and certainly what happens, it will be redirected here. It will be redirected. So this is what hash table is all about. We have already discussed hashing technique, and we discussed there are four methods. So I talked about the division method, multiplication method also. The next method I had to talk about mid-square method, and another one is fold method. And of course, in the examination for your syllabus, you have only these two, But it is good to know about this also. Uh, in fact, it is very important. So we know hash function is a function that is used uh, to put data in the hash table. It is some calculation. You can see the data, it is coming and it is giving to a hash function, and finally this hash function data is showing some index, and in that index this particular data is going to be stored. So that is the concept that I have already explained to you in earlier class. So this is your x mod m, that is division method, where you modulus, you divide whatever the modulus you get. So in that value, uh, uh, index number 70, you are going to store, in index number 70, you are going to store this 1, 2, 3, 4. 1, 2, 3, 4. And m is nothing but the size, total size of your hash table. We have already discussed in the class. I think last class, concluded class, I have already discussed. So I think certainly you can uh, refer to my notes also. Notes I will be giving by end of this day, today or tomorrow morning I will be giving. And similarly, if you calculate, so here, what is the size of m? What is the value of m? By looking at this calculation, what is the value of m? Anybody in the class can type it in the chat box. What is the size of m? Yeah, most of you, I want you to be interactive. Kindly type in your response. Yes, some student has typed. So size of hash table. Now by looking at this calculation, what is the size of the hash table? What is the size of the hash table? By looking at this calculation, what is the size of hash table? Yes, Amog Kota, you're right. And I want everybody to be active, and you have to see the question itself. They are given the size. If n is nothing but the number of elements. Or so in some books they write it as m, the number of elements. So that element only it is used for modulus calculation. So now in index number 16, in the index number 16, so what happens, you store 5642, you store 5642 in index number 16. So the total size that you can expect, uh, is total size you can expect is 97. So it starts from 0, it ends at 96. So the last cell number is 96. The first cell number is 0. So this is the hash table. In the hash table in 70 you store 1, 2, 3, 4. How it is calculated? So you modulus by the total size. So based on this division method, this is the formula you apply, and based on that formula, so you can certainly calculate. So that is 70 is the location where 1, 2, 3, 4 is stored, and of course um, 5642 is stored in 16. It is stored in 16. So this is the division method. And another example, this also I have already covered this in the class. So the total size is 5. So the total table size is 5. So table size 1, 2, 3, 4, 5. So here m is 5. So when m is 5, so everything you have to modulus by 5. So 4 modulus 5 is 4 only. So object 1 is going to be stored in 4. And object 2 value is 16. So 16, it is stored as so 16 modulus 5 is 1. So object 2 is stored in 1. And object 3 is 68. It is stored in 3. Yes, 68 modulus 5 is 3. So it is stored in object 3 is stored in location number 3. Same way object 4, its value is 125, which is storing 125 is storing the modulus value of 125 is 0. So object 4 is straight away stored in 0 location. So it is like this, it has to be calculated, and finally it has to be stored. So that is hashing. This is also another example that I have given in the class. Also we have solved a few examples based on this hashing. So, and this hashing also have explained, and you have worked, in fact you have worked this, and this is multiplication method. In multiplication method, what you do, you multiply the size. You are not going to divide it, you are going to multiply it, and you multiply with a constant k, which constant a, so which is multiplied to k. So the a value which will fall between 0 to 1. So either 0 point something it will hold. So when you do modulus, you can extract only the decimal part. So here is one simple example. So if a value is 0613, so and m is total size is 1000, k is 1235. So where does 1235 store? So 1235 that is the k value. So this is your key value. A value they have already given. you multiply these two first. So when you multiply these two, one second, I just clear the, once you multiply these two, so this is A value, this is A value modulus 1 into 1000. So when we multiply these two, so you get 7629 point something. So when this is multiplied with the constant, so A is a constant which will be given in the problem itself. And once you modulus, so automatically what happens? You lose this uh, decimal value, the integer value you lose, you get only the fractional values. So fractional values are 6173 something. If you multiply by 1000, 1000 is the size, total size of the table, the hash table. So the hash table size is 1000, and once you multiply, you'll get approximately 617.385, so which is equal to 176. So the value 1234 will store in 617 location. So 1234 is 345 is going to be stored in 617 location. So that is how you do multiplication method. So similarly, another example. Here, A value, that is constant value, is 0.3. So multiply K into A, that is K value is 6, and A value is 0.3. So when you multiply, you get 1.8. So 1.8, and M size is 32. So you have 32 cells. So that means cell number 0 is the first one, and the cell number 31 is the last one. And you multiply this, you modulus this by 1. When you modulus this by 1, you get a 0.8, 0.8. And this 0.8 you multiply with uh, 0.8 with 32, so you get 25.6. So the rounded value or only the integer value is 25. So 25th location, in some 25th location, so you are going to store the value 6. 6 is stored in 25th location. This is another calculation. This is how you calculate. Mid-square method. Mid-square method is in the next method. I think we don't have time to um write it down and all those things. So you can take the screenshot of this so that you can write it later. So this is the third method. The first two methods are division method and multiplication method. Third method is mid-square method. So what it does is it will first calculate the middle value. So if you understand, uh, this is the key, so then what it will do, it will find the k square, the key values square, it will calculate. When you square it, 1 2 3 4 square, you get 1 5 2 2 7 5 6. So this is the key value. So out of which you have to take the 3 digits, the 3 values or 2 values. Those are the middle square method. So now 2 to 7 you got. So in that, either you have to take 2 2 or 2 7. So since you are having, so this is the middle, correct? No, this is the middle. Sorry, 2 to 7 is the middle. I just take the eraser and erase it. Yeah, this is the 2 to 7. So either the middle value is 22 or 27. So it will be stored either in 22 or 27. So in 27, the value 1 2 3 4 1 2 3 4 is stored. 1 2 3 is stored. This is called mid-square method. And for this mid square method, so take another example. Say, for example, key 5642, you are having the key, it has to be inserted into the hash table. For this, you need to calculate the square first. So you square it, you get 3183216 4. So the middle elements you just take, you get 3 2. So the middle, whatever the middle element you get, that is 3232, will be the location where this 5642 has to be stored. So it is in 32 location, 32nd location. So 5642 is stored. So 5642 is stored. So this is called mid square method. So remember one thing we have already discussed. We have already discussed division method. We have already discussed multiplication method. Now we are discussing mid square. So whatever the key you want to insert into the hash table, what do? You square it, and the middle elements, either 2 or 3 elements, so it has to be taken, and it has to be uh, decided, so that you can store that particular key value into that particular index location. So this is about mid square method. The next method is folding method. What it does is it folds. So folding method works in following two steps. First thing, it divides the key into number of parts. It will divide the key into number of parts. So say for example, if you have a key value k, that it is divided into k1, k2, k3, k4, k5 up to kn, where each part has the same number of digits except the last part. Last part may have lesser number of digits. So what you do, this add all these individual parts, that is obtain the sum of k1, k2, k3, k4 to kn. Each the hash values by obtaining by ignoring the carry value. So that is folding the carry value. So usually note that the number of digits in each part of the key vary depend upon the size of the hash table. For example, hash table of size 1000, then there are 1000 locations in the hash table. The address, to address these 1000 location, we need at least 3 digits. So therefore each part of the key must be 3 digits except the last part, which may have lesser digits. So that is folding methods. Actually fold shifting we can do, fold boundary method. There are two methods. So suppose if you have 100 locations, take for example, if you have 100 location, calculate the hash value using folding method for the keys 5, 6, 7, 8 and 2, 3, 1 and 3, 4, 5, 6, 7. So let us take the first one. Uh, let us take the first one. Yeah, let us take the first one. So it is 5, 6, 7, 8. So you divide it into two parts. So equal parts, you divide it into two equal parts and add up these two. So 5, 6 is 11. 11 if you add, it becomes 2. You add 7 and 8, it is 15. So 15, 1, 5 if you add, you get 6. And 6 plus 2 is 8. So in 8th location, you just store 5, 6, 7, 8. Similarly, 3, 2, 1. So if you look, if you make equal partitions, so it is single partition, 1, 1 partition. So 3 is partition 3 plus 2 is 5, and of course 5 plus 1 is 6. So in the sixth location, you are going to store this 3 to 1. Similarly, you can also use 3 4 3 4, one partition, 5 is another partition, and 5 6 and is another partition, 7. So the last is not so now you certainly fold. So when you fold it, 3 4 is 7, and 5 6 is 11 and 7. So you add up all these things, certainly you get so 18 plus 7 is 25. 25 plus 2 plus 5 is 7. So in the seventh location, this entire value is stored. So it is just like that. You can certainly calculate. So same way with the boundary method. Now, I think when we are inserting, if two numbers get the same index value, if the two keys gets the same index value, that is same index, so you get collision. So you get collision. So collision you are going to get. So how to resolve this collision? So that is the first point that you should understand. So whenever you calculate this, you got all these values. There are 9 slots when you calculate. So 6 is unique, 7 is unique, 5 is unique, 8 is unique, 1 is unique, 4 is unique, 7 is a clash, 1 is a clash, and 7 is a clash. So there are 3 numbers that you got clashes. So how to avoid this collision? So in order to understand what is a collision, collision occurs when a hash function maps two different keys to the same location. So if you map two different keys to the same location, then collision happens. And two records cannot be stored in the same location, so any one has to be stored. So therefore, we need to devise a method that is used to solve the problem of a collision. This is called collision resolution technique. So there are two popular collision resolution technique. So one is open addressing, another one is chaining. Let us talk first about chaining. Chaining is very easy, that's why I'm taking chaining. Later we will talk about open addressing. In chaining, what happens? So if collision occurs, so look at here. So for this value 3, you can see K2 is also one element and K6 also one element. Both are getting the same location. There is a collision. So when you have collision of two keys like this, what happens? It will create a linked list chain. You can see the first number occurred, it will be the first node. Second number with the same collision, so it will be stored in the chain. So K, it's a linked list kind of thing. So in chaining, each location in the hash table stores a pointer to a linked list that contains all the key values that are very hashed, that were hashed to that particular location. So you have a linked list, and if no element is available, so then what it will do? It will hold null values. It is holding null values. So this is what you call it as collision resolution by chaining. So look at here. I want to store these values 7, 24, 18, 52, 36, 54, 11 and 23. And total size of my table is 9. So that means it starts with 0, it goes up to 8. The first, and I use a hashing method. That's a division method. uh, Hash of k is equal to k modulus m. So m is the size. Now take the first one. So m is initially 9 and 7 modulus 9 is 7. So in location 7, so what happens? 7 is stored. Similarly, 24 modulus 9 is 6. So the sixth location 24 is stored. Similarly, 18 modulus 9 is 0. Exactly, it will store 18 in 0th location. And 52 modulus 9 is 7. And of course, there is a collision. So if collision is there, no problem. It will create a linked list, another linked list node, and it will link. So next 36. 36 is again resulting to 0. So what it will do, it will create this collision. It can be resolved using chaining, that is linked list chain. It will create a linked list chain. Similarly, 54 modulus 9 is 0. So it will create one more chain. Yes, very simple. So this is the thing. And 11 modulus 9 is 2. So 2 is empty. Okay, it will store. 2 is null, it will store. So similarly, 23 modulus 9 is 5. So it will store like this. So wherever there is a collision, what it does is it will create a chain. So this is a technique. This is an example for collision, which is collision resolving technique, that is chaining. The next technique is open addressing. You observe here, in some positions, null values are there. Even though null values are there, so whenever you are storing simply null values, you are wasting your memory. You are underutilizing your hash table capability. So in order to avoid this null value storage, the hash table, so we go for open addressing. In open addressing, what happens? So there are 4 types of open addressing. So uh, one is linear probing. The second one is quadratic probing. Third one is double hashing. The last one is rehashing. So what is exactly linear probing? So you can see, once collision takes place, open addressing or close addressing computes a new position using a probe sequence. It will calculate the probe, it will does the probe sequence, and it will calculate. And the next record is stored in the position, in that particular position. If there is a collision, it will calculate. It will go for calculation, that is probe. So can you please, some student has given a message. Uh, can you show previous slide? Yes. Yeah. Amok Kota. If you are willing, you can unmute and you can talk, Amok. You can ask doubt. Any doubt is you have? So kindly take the screenshot. If you are looking from screen, okay, I just clear everything. So yeah, got it, sir. No problem. So I'm able to access to your messages. I'm on. Yeah. Yes, somebody wants to talk something. Yeah. Uh, I think it was by mistake, I believe. So whenever there is a collision, and if the location is already taken by some element, so then you have to find a new location instead of making a chain, instead of making a chain. So what we want is, we want to make one more position, we have to find one more position. The process of finding the new position for an element that has already met with a collision, that process you call it as probing. So there are four types of probing: linear probing, that is finding the new location for a collided element; quadratic probing; double hashing; and rehashing. So let us see in the examination. Don't get confused. There are four hash functions. There are four hash functions, and there are two collision resolution CRs, two CRs, resolution techniques. The first one is chaining. Second one is open addressing. Open addressing. In open addressing, we have four types. So those are the four types: linear probing, quadratic probing, double hashing, and rehashing. So understand that. So first, let us look into linear probing. Linear probing, this is the formula. This is the formula for normal calculation. If there is a collision, it is the simplest approach to resolve the collision by linear probing. So in this technique, if the value is already stored in the location generated by the hash function h of k, then the following function is used for linear probing. So it will add a value I, which is a probe value. I is a probe value, and it will calculate. So where m is the total size of the hash table, and hash dash, so hash apostrophe, you can see hash apostrophe k, it is a hash function that is earlier used for calculating the location for a key k, and that location is met with a collision. So what happened? You added a probing value. So probing value is I. So usually probing value starts from 0 and it goes up to m minus 1. So therefore, this is a mathematical value. Therefore, for a given value of key, first you generate the initial location, and if the initial location you found is added with the probing value I0, if the location is free and the value is stored in it, that is k value is stored in it. If not, secondary probe generates. So whenever you want to go for secondary probe, the I value will increase. I value will increase. So earlier I value was 0. Now I value became 1, and it checked h dash of k plus 1. It added and it checked whether it is available or not. If it is available, it will store. If it is not available, it will go to the next probe. So in that probe, I value gets increased to 2. If it is not available, it will increase to 3. If it is not available, it will increase to 4. If it is not available, it will increase to 5. So until you find a free location, so you keep on probing. That is what you call it as linear probing. So linear probing is what it is checking. So let us look into this with an example. Look at here. I think you have to consider a hash table with a size 10 and using linear probing. And probing when there is a hashing, when there is a collision in hashing. So if there is no collision, no probing and all will come. Okay. Now insert key 72, and you know very well 72 is modulus by size m, that is 10. So the modulus you get is 2. So in the second location, So this is the 0th location, this is the first location, in second location 72 is stored. Next 27, so in the 7th location 27 is stored. Similarly 36 is stored in 6th location. 24 in the 4th location. Next 63 in the 3rd location. 63 in the 3rd location. 91, 81 in the and you know 92, so it is in two position, it is not available. So it will check, it will have a collision. Whenever it is having collision, then it will go for linear probing. So that's the concept that you have to understand. Look at here, hash h dash of k, which is initial probing, k modulus m, where m is equal to 10. So the first initially every element is empty, that is empty, you write it as -1, and 72 is the first key that you have to do probing. 72 modulus 10 is 10 plus I value initially it is 0. So you observe I value is initially 0, modulus 10. So 72 modulus 10 is 2, 2 modulus 10 is 2. So it will be available, it will be stored in second. 72 is stored in second location. Next element is 27. 27 is 27 modulus 10 is at 0 location. Yeah, 7th location. Similarly, 36 in the 6th location. 24th in the 4th location, then 63 in the 3rd location, then 81 in the 1st location. So this is up to here, everything is fine. So 27 you entered, 36 you entered, 40, 24 you have entered, 63 you have entered, 81 you have entered. So now the element comes is 92. So these are all already stored. Now the element that you get is 92. 92, hash of 92 comma 0 is nothing but 92 modulus 10 plus 0. 92 modulus 10 is 2. You get 2 modulus 2 is, so second location which is occupied already. It is already. So what happens? Cannot store it in the table, hash table of 2. So the probing value will increase to I. With I earlier it was 0. You can see here it is 0. Now it is increased to 1. So it will increase to 1. So when I is increased to 1, it is 92, h of 92 comma 1. So earlier h of 92 comma 0. So as I said, every time collision happens, it will keep on increasing. So it will check. So now it will check for the location 3. So 2 plus 1, 3. So 3 is also occupied. So automatically the probe value, which was 1, is increased to 2. So now 92 comma 2. So it will check for the next element. 92 comma 2. So you get 4th location. 4th location is also occupied. So first it will check 72, 72, then 63, then 60, 24. Next, so I value is increased to 3. So 92 modulus 92 comma 3, 92 modulus 10 plus 3. So you 2 plus 3 is 5. So the fifth location is free. Fifth location is free. So you can see fifth location is free. So in that location, so is available. In that location 92 gets stored. So this is what you call it as linear probing. In linear probing, it will check for the linearly the elements and later it will probe. It will probe. So this is linear probing. So the next element 92 is done. Next 101. 101, so which is modulus is 81, which is already filled. So it will check the next cell, it will check the next cell, it will check next cell, check the next cell, it will check the next cell, it will check the next cell. Oh, it will check the next cell. So here it is available. So 101 is stored in 108. So that's what you can see. It's available. It's available. Similarly, it is available. It will go up to 7. And when probe number 7, so it will 8 is available. So in the 8th position, 101 gets stored. Yes, you can see 101 gets stored. So this is what you call it as linear probing. This is what you call it as linear probing. So with this, I just take a pause in the class. So let us go back and understand what we have learned today. So tomorrow also at 7 o'clock evening, uh, I will take a class, online class. I'll finish the rest of the things. And there is one more lab program in modulus 5, in module 5, based on hashing. I'll explain that in tomorrow's class. So tomorrow, some students are going in the morning to Indian Institute of Science, so it is not possible. And evening 7 o'clock, we shall have same 45 to 50 minutes class. I think you can all use the same Google Meet link, whatever I have shared today. The same link you can use, and we can join for tomorrow with the same link. We can join, and until then, have a nice day, nice weekend. Thank you. So, if you have any concerns or anything, you can write to me over this email ID. And for notes and other things, you can refer to my